Most planets behave like cosmic sponges. As they orbit a star, their atmospheres and surfaces soak up incoming light, capturing that energy as heat. But astronomers found a world defying this pattern, completing a full orbit around its star in less than 1 Earth day. At this extreme range, unrelenting solar radiation bombards the planet. The star's sheer intensity should scorch the surface and strip the atmosphere entirely. Under standard conditions, this proximity to a star creates a lethal environment where planetary survival is essentially impossible. Despite that incinerating orbit, telescope data confirms the planet is still there, fully intact. This chart tracks the luminosity of various exoplanets. While typical rocky worlds sit at this low baseline, our anomaly planet produces a massive vertical spike. It is one of the brightest objects ever discovered in the known universe. This world sits directly inside a cosmic furnace, maintaining a brilliant sheen that contradicts the expected physics of heat absorption. The temperatures on the day side are high enough to liquefy solid rock and bring dense minerals to a rolling boil. That extreme heat triggers a phase change, turning molten metals into rising atmospheric vapor. Reaching the cooler upper atmosphere, this vapor consolidates into thick, dense cloud layers. This creates a planetary-scale environment dominated by churning clouds made of heavy metal particles and vaporized rock. The star's intense heat provides the raw materials required to build this protective metallic atmosphere. These clouds interact with stellar radiation through a process called albedo, or planetary reflection. Composed of metal, these clouds bounce 80% of incoming starlight directly back into space. By comparison, Earth reflects only 30%. This scale of deflection is unlike anything in our solar system. This high reflection rate creates a survival loop. By deflecting the majority of the incoming energy, the clouds act as a thermal shield that protects the lower atmosphere and the core from vaporizing. The planet used its own melted crust to forge a literal cosmic mirror. For years, astronomers have observed the Neptune Desert, a region near stars where planets of a certain size were thought to be impossible because the radiation would destroy them. This scatterplot maps planetary mass against distance from a star. This empty space is the Neptune Desert. Yet we found this mirror planet sitting directly inside that dead zone. This discovery means that our simulations for planetary survival must now include metallic cloud formation as a primary mechanism for resisting stellar radiation. It suggests that our previous estimates for the limits of the universe were far too conservative. High-stress environments in space can drive the creation of complex physical defenses rather than just resulting in total destruction. This world exists in a state of permanent, apocalyptic heat, shielded by a shimmering umbrella of liquid metal. This planet entered the fire and emerged as a perfect mirror.